You'll recall from our earlier conversations that there's a set of rules that applies to standard form categorical statements, and we can use these rules to both create new statements that have known truth values and to evaluate arguments for validity. So you see here, for example, all of the rules associated with the traditional square of opposition, the rule of contrary and subcontrary, subalternation, contradiction, conversion, aversion, and contraposition. And we can use these rules to determine whether or not the conclusion of a given argument follows with logical necessity from its premise. So for example, in this argument, all dogs are canines, therefore it is false that no dogs are canines. We recognize that we have corresponding A and E statements. The premise is an A statement, the conclusion is an E statement that's being offered to us is false. We know by the rule of contraries that given corresponding A and E statements, at least one of them has to be false. So in this case, if the premise statement, all dogs are canines, is true, the corresponding E statement has to be false, and that's exactly what the conclusion here says. And so we can say, well, this argument is valid, and it's valid by the rule of contrary. That conclusion follows with logical necessity from the premise because of the rule of contrary. Similarly, we can look at an argument like this. Some dogs are canines, therefore all dogs are canines. And again, we recognize, we have corresponding statements. The premise is an I statement, the conclusion is an A statement, and their subject and predicate terms are identical. That starts to sound a little bit like subalternation, but remember that in subalternation, the falsity floats from the I statement to its corresponding A statement, and the truth trickles from an A statement to its corresponding I statement. And in this argument, we see that the person is claiming that because the I statement premise is true, the conclusion A statement would therefore also have to be true. And we say, no, that's not the way that subalternation works. This is an invalid argument, and it's invalid because of illicit subalternation. It breaks the rule of subalternation. So even though both the premise and conclusion statements in this argument are true, it's by sheer coincidence, right? This is the broken clock that's right twice a day. It's by sheer coincidence that the conclusion is true when the premise is true. But we know that it's not by logical necessity because that's not how subalternation works. Now, the cool thing for us is that there are some rules that apply not just to standard form categorical statements, but to standard form categorical syllogisms. And there are only 5 of these rules. And if a categorical syllogism breaks any of these 5 rules, just one, that argument is invalid. But if it doesn't break any of the 5 rules, it's valid. And the good news for us is these rules are way simpler than the rules of conversion, aversion, contraposition, and subcontrary. These rules are going to be really easy for us to grasp. And once we have them, we can now add to our toolbox an additional way to check our work so that we can look at an argument's form and determine whether or not it's valid or invalid, its Venn diagram, and then apply these 5 rules to see if it doesn't break any of them. And that'll tell us this argument is valid. Now, the first 2 rules deal with the concept of distribution. So our goal here now is to get really clear about what exactly distribution is. Our arguments involve standard form categorical statements that have 2 terms, a subject term and a predicate term. So for example, in this statement here, all skateboarders are CR students. We have skateboarders as our subject term and CR students as our predicate term. A term is distributed if the statement asserts something about every single member of that term. Okay, so you look at a statement like this, all skateboarders are CR students, and the question we would ask ourselves, is this statement telling me something about every single skateboarder? Is it telling me something about every single CR student? And the answer is, well, yeah, it's telling me something about every single skateboarder. Every single one of them, all of them are included in the category called CR students. Okay, it's not necessarily telling us something about all CR students because there could be CR students that are not skateboarders, and it still be true that all skateboarders are CR students. But it is telling us something about every single skateboarder. And so we say that term is distributed. And to make clear to ourselves that this term is distributed, we're going to mark this little D next to it like that. Now consider a statement like this. No skateboarders are men. Is this statement telling us something about every single skateboarder? Is it telling us something about every single man? And the answer is, well, yeah, it's telling us something about every single skateboarder. None of them are included in the category of men. And the statement is also asserting to us something about all men. None of them are included in the category of skateboarders, because if they were, it wouldn't be true that no skateboarders are men, because those men would be skateboarders. Okay, so this statement is distributing its subject term and its predicate term. Now consider a statement like this. Some men are CR students. Is that telling us something about every single man that exists? No, it's telling us about some. Is it telling us something about every single CR student that exists? Well, no, it's just telling us about some. Some men are CR students, some CR students are men by conversion. So an I statement like this doesn't distribute anything. It's not telling us anything about all of the subject term or all of the predicate term. Now think really carefully about this statement. Some skateboarders are not men. Is this statement telling us something about every single skateboarder? You say, well, no, it's just saying something about some of them. Is it telling us something about every single man? And the answer is yeah, and it's kind of tricky to understand why. So imagine this. Imagine over here, I have in this building every single man that exists. And I have over here some number of skateboarders. Who knows how many? Some of them, 10 of them. And I'm looking at these, and I'm saying, well, looking at these 10 skateboarders, do I know something about every single skateboarder? And it's like, well, no. I just know something about however many there are standing over there. But now I look over here at this container, this building that's housing all these men, all the men that exist, and I notice something about every single one of them. None of them are those skateboarders over there. So in that sense, this statement distributes its predicate term. Okay? Now, what's cool for us is that every single A statement, no matter what the subject and predicate terms are, distributes its subject term. And every single E statement distributes both its subject and its predicate terms. And every single I statement distributes nothing. And every single O statement distributes its predicate term, right? And there's a pattern here. Universal statements like A statements and E statements, they distribute their subject terms. And negative statements like E statements and O statements distribute their predicate terms. So there's kind of a pattern here. And these first two rules that we're going to look at, they rely on this concept of distribution. And because these terms are always distributed or undistributed in these types of statements, it's going to make evaluating arguments very predictable, very reliable. We just have to get comfortable with these 5 rules, and that's what we're going to do next.